This video covers Pre-Calc Notes 9.7. The topic is probability. Let's first start off by defining what probability is. It's the measure of the likelihood that an event will occur. I've given you a formula over here for finding probability. The way you find the probability of event E, so some random event, would be taking the favorable outcomes, so the number of ways that that outcome that you're looking for can occur, over all of the possible outcomes that you could possibly get. And when we think about probability, probability is always a number that's between 0 and 1. Now when we give our answers as probability, I want you to give them as fractions unless it specifically says round it to a certain number of decimals. So we're going to be giving our answers as fractions. Sometimes, and this is another way you can give your answer, but again, I want you to try to always use fractions. Sometimes you can give your answer as a percent between 0 to 100%. 0 meaning that the event will never occur, 100% meaning that the event will occur every single time. Okay, so applying the formula to an example, what is the probability that you roll an even number on a six-sided die? So we'd write the event like this, probability of an even number, and we'd have to think about all of the even numbers on a die. Make that a little bit neater. And we would divide that by the total numbers on the die. So even numbers would be 2, 4, and 6, so that's 3. Total numbers, there's 1, 2, 3, 4, 5, 6, so 6 numbers. So the probability would be 1/2. Or we could write it as 50% if we wanted to, but I would prefer that you give your answer as fractions. What about this one? What is the probability that on a six-sided die you get a 5? So P with a 5 there means the probability of rolling a 5. So it would be the number of 5s on the die, there's only 1, out of 6 total. So it would be 1/6. Probability of not a 5. Well, there's two ways that you can do this. You can go through and you can say, well, how many are not a 5? There's 1, a 2, a 3, a 4, and a 6 is basically what that's asking. Probability of getting any of those. And that would be 5 different ways over 6. So that's one way you could do it. Or you can use the complement. And here's what the probability formula for the complement is. It is probability of not A would be equal to 1 minus the probability of A. Sometimes you'll also see it written like this. A little line above the A meaning not A. So if I want the probability of not 5, I could do 1 minus the probability of 5. And we already figured out the probability of 5, it was 1/6. So when I do 1 minus 1/6, I get 5/6. Now in a problem like this, it's probably just easier for us to count the numbers that are not 5 and get 5/6, as opposed to using this formula here. But this formula is going to be a lot easier to use when we have bigger numbers that we're dealing with. So I would recommend that you write this formula down, and sometimes we'll apply the complement formula as opposed to actually calculating the probability of our event. Either way, you'll notice that I got 5/6 as my answer. And this way took a little bit longer, but that's mostly because I had to explain what the formula was versus just counting out 1 through 6 and not including 5. Okay, looking at the next example, it says you toss a coin and you roll a six-sided die. So what we're doing now is we're doing two events. So we're talking about the probability of if you're tossing the coin getting a tail, and when you roll the die getting a 4. So when we have the probability of multiple events, so probability of A and B, we want to use this formula. Take the probability of A and times it by the probability of B. So that's a formula that you're going to need to know. So applying that to this, I would take the probability of getting a tail, and I times it by the probability of getting a 4. Well, on a coin, there's only 2 outcomes, a head or a tail, so it'd be half would be the probability of getting a tail. Probability of a 4, there's only 1 4 out of 6 total, so my answer would be 1 in 12. that I could get both a tail and a 4. If I think about the next one, probability of head and odd, and meaning again multiplication, so just like my formula says here, we see probability of head times the probability of an odd number. Well, again, a head, there's 1 out of 2. Odd numbers would be 1, 3, and 5, so that's 3 out of 6. So this would give me 3 out of 12, which I can reduce down to 1/4. So when you see the word and, okay, make sure that you understand that the word and means multiplication. That's important that you know that, because as we progress through these notes, we're going to change the word to or, and or is going to mean addition. So you need to recognize and is multiplication, or is addition. Alright, in the next one it says, in a deck of cards, find the probability of getting the king of hearts. So if you're not familiar with a deck of cards, there are spades, clubs, hearts, and diamonds, and there are 4 of each of those cards. And then there's 13 different cards altogether, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king, and ace. So I've listed those off to the side here. That's really helpful for those of you that aren't familiar with cards at all. So what we need to know is that there's 52 total cards. And there's 4 different suits: spades, clubs, hearts, and diamonds. So if I'm asking you to find the probability of getting the king of hearts, well, there's only one king of hearts in the deck. That would be this card right here. So the probability of drawing that card would be 1 out of 52. Probability of getting a diamond. Well, if I think about the diamonds, all of these are diamonds. So that's 13 cards total. And there's 52 total cards in the deck, so it'd be 13 out of 52, which is a quarter of the deck. If we think about red cards, let me erase this over here. We think about red cards, well, there's 2 suits that are red and there's 2 suits that are black. So these 2 suits here are black. I should write that in black. These 2 suits are the black suits, again, if you're not familiar with black and red cards in the deck. And those would be the red cards. So how many of these cards are red? Well, if 2 of the suits out of 4 of the suits are red, that would be 26 cards out of 52, which is half of the deck. And finally, the last one is the probability of getting a 7. So you'll notice that there are 4 different cards that have 7 on it. So the probability of getting a 7 would be 4 out of 52, which is 1 over 13. So as you're doing these problems, again, please take the time to write them as fractions, and if you can reduce the fraction, then go ahead and do that. Alright, the next one says, what's the probability of not getting a 10? Well, I could count up all of these, or I could use combinations to help me with that. So I'm going to choose to go not, I'm going to use the combinations formula. Sorry, I'm saying combinations, I mean complement formula. I'm going to use the complement formula that we talked about a little bit earlier in the notes to do this problem. So let me make some more room here. So we had talked about complement formula, and I wrote it down earlier because I used it earlier in the notes. You'll notice that there's another way that you can write the complement. You can use this little prime sign here. You'll notice that before when I did it, I wrote it as P of A with a bar over it. That means the same thing as not A, and A with a little prime next to it is the same as not A as well. So you can use it either way. Sometimes the book will give it to you this way, so that's why it's important you see both. So the probability of a complement would be, it'd be easier for me to, with this problem, to find the probability of A being, in this case, specifically a 10, and then go through and subtract it from 1, as opposed to counting up all the cards that are not 10. So what I'm going to do is I'm going to do 1 minus the probability of a 10, and that's going to give me the probability of not 10. Or I could put a little prime next to that instead of the bar above it. So I would look at this and say, well, there are 4 different 10s out of the 52 cards. So that's 1 minus 1 over 13, so that's 12 over 13. So again, this is an example where Yeah, I could, because I've listed them all out. I could count to see how many cards there are not tens, but I think using the complement is much quicker of a process for a problem like this. Okay, in the next example, we're going to shift gears a little bit, and now it says, in a deck of cards, I want you to find the probability of a 5 or a J. Okay, so we need to talk about the probability of event A or event B. So when I change the word to or, what you need to do is find the probability of A, add to that the probability of B, and then subtract from that, and I should have given myself a little bit more room, probability of A and B. So I'm going to have to put that down here, minus the probability of A and B. So that's my formula now. So this right here, when I say minus the probability of A and B, what that will do is that will eliminate the duplicates. Because sometimes the card that you're dealing with can be counted twice. And if you count it twice, then that's not going to give you the exact probability of the event that you're dealing with. So that's where the term mutually exclusive and not mutually exclusive occurs. So when I look at probability of a 5 or a jack, there is no card in my deck of cards that is both a 5 and a jack. So these are mutually exclusive, meaning that they cannot occur at the same time. With drawing one card, I cannot get a 5 and a jack. Okay? But, on the other hand, if you have a queen or a diamond, because there is the queen of diamonds, this would not be considered mutually exclusive, which means that they can occur together or at the same time. So you could reach in to, let's say you have a deck of cards in a bag, and you could pull out the queen of diamonds. So when you're counting the probability of queens, and you're counting the probability of diamonds, both of these cards would be, both of these probabilities would contain the card queen of diamonds and queen of diamonds. So you'd actually count that card twice. That's why you have to subtract the probability here of A and B, so you can eliminate the duplicates. You don't have to subtract when they don't occur together. But I always subtract, and then you'll know when you don't have to subtract. Here's what I mean by that. If I ask you to find the probability of 5 or J, you'd find the probability of 5 plus the probability of a jack minus the probability of a 5 and jack. I'm going to erase this so I can write my answer underneath there. So the probability of a 5, well, there are 4 5s in a deck of cards. And there are 4 jacks in a deck of cards. How many 5 of jacks are there in a deck of cards? Well, there aren't any. So it'd be 0. So really I don't have to subtract anything because I'm subtracting 0. So because it was mutually exclusive, I really don't have to do that part. So I'd get 8 out of 52, and that reduces down to 2 over 13. But if I tell you that sometimes you have to subtract and sometimes you don't, you'll forget the process of when you do have to subtract. So always subtract, and it'll take care of itself if you don't really need to do that part, because there were no 5 and jacks that were one card together. Alright, so let's look at the next one. A queen or a diamond. So we're going to find the probability of a queen plus the probability of a diamond, and we're going to subtract from that the probability of the queen of diamonds. So there's 4 queens. Diamonds, that's 13 out of 52. And there actually is 1 queen of diamonds in a deck of cards, so you've got to subtract that, because that's occurring in both of these counts. So this would be 17 out of 52 minus 1 would be 16 out of 52, which will reduce down to, I can divide those both by 4. So 4 over 13. So again, when you're dealing with the word or, you have to remember that or means to add and then subtract the duplicates. If you're dealing with the word and means that you're going to multiply. So you have to keep those two probability formulas separate in your mind. And again, I would make sure that they're highlighted so that they become part of my note card.